Hello everyone, my name is Michael Cook. I'm an AI researcher at Falmouth University and a game designer under the name Cut Garnet Games. And this is a talk I wrote for EGX, the Eurogamer Expo in September of 2016, and recorded to put it up on YouTube later on. The title of the talk is We've Run Out of Planets, Procedural Generation After No Man's Sky. And it's a talk about the use of scale in procedural generation, what it means, why we used it, and what other things maybe we could do in the future with procedural generation. As I said, my name is Michael Cook. I am interested in procedural generation and computational creativity. Most of my research work revolves around developing a piece of software called Angelina, which I did for my PhD. Angelina was an AI project that attempted to design games on its own. It designed games like 2D platformers based on news articles, or 3D maze games like the one pictured here, based on game jam themes. It would download information from the internet and try and justify some of its design choices. You can play all of its games at gamesbyangelina.org if you're interested. And I've got some other research projects on the side, but Angelina was always the main focus. I also make games in my spare time. I'm currently working on a game called Rogue Process with Marsh Davies. Rogue Process is a 2D action hacking game with a lot of procedural generation and AI in it. We're procedurally generating things like corporations, their slogans, their logos, the skyscrapers they have their HQs in, the city blocks that those skyscrapers are based in, the cities that those blocks compose up. We're generating all sorts of stuff, and there's a lot of interesting stuff going on, and a lot of interesting stuff that we've got planned for the next few months. So if you're interested in following along as I finally get a chance to work on it, you can check that out at rogueprocess.run. Finally, another thing I'm really interested in is broadening the procedural generation community, getting new ideas in, new people to meet each other, and exposing procedural generation to more people. Every year I organise ProcJam, the Procedural Generation Jam, where people get together for a week and make things that make things. Sometimes these are games, sometimes they're toys or experiments, sometimes they're art installations or Twitter bots, and sometimes they're all of those things at once. We also have a day of talks which we stream live from Falmouth this year in Cornwall, but I'll give you some more information about all of that at the end. But I'm really interested in the other things, the new futures for procedural generation. Today I want to talk to you about big numbers. And big numbers as they infiltrate the world of procedural generation and how they influence our lives, our games, how we design games, how we play games, how we market games, how we think about games. And it's about specifically how that's changed over time and how it might change in the future. By the way, just really cling on to those jokes, because there's not going to be, it's not like, it's not packed with them. So this was a good one. I'm just warning you in advance. I'm also going to talk about our obsession with those numbers. So why is it that they capture us so much? Both the people who design generators, we get super interested in them. The people who write about them always had, big numbers are always a great hook. And obviously the people who play those games and are excited for them, which is all of us. We're all enticed by these big statements about the potential of a generator. And why is that? Why does it grab us? And we're also going to think about whether, have we seen the last of them yet? No Man's Sky was released this year. It had a very big number attached to it. Will that be the biggest number we ever see on the marketing for a procedural generator? Or can we go even bigger than that? Does the future just keep on going up? Well, the only way to look at the future is to start by looking backwards. So let's go on a history tour of silly numbers in games. And we're going to go back to start in 1984. Elite wasn't the first game to use procedural generation, of course. Procedural generation goes back before digital games. You could send off in the post for a random dungeon, and it would come back on printer paper a few weeks later, and you'd have randomized puzzles and monsters to defeat in a kind of choose-your-own-adventure book. But Elite is an interesting case, especially for numbers and marketing and procedural generation. And we'll find out exactly why later on. But all you need to know for now is that Elite had 8 galaxies in its game, which you could fly around as a pilot or a pirate or an explorer or a merchant. And each galaxy had 256 planets in, which means in total there were 2,048 planets in Elite. And at the time that was a big deal. The developers had found a way to express planets and stars as just a few numbers which would be multiplied together and expanded out to give all of the data that they needed to describe the places that you visit. And that was important because games had to be distributed on quite small disks, so there wasn't much data around, and being able to store 2,000 planets on such a small amount of storage space was a revelation. It was a really crucial thing that made Elite what it was. To skip forward a bit, the next milestone I want to point out actually happens quite a few years later. Borderlands is one of the first games I can remember that really tried to sell the scale of its procedural generation, and in a very specific way, to market the game. Borderlands was a first-person shooter that generated its own guns, which was a little bit unusual. Even though we'd had games like Diablo that generated loot before, generating guns in a 3D first-person shooter was not very commonplace. And Borderlands was very keen to impress upon people how many guns it had in it. It had 17.75 million guns, which was quite a large number. The developers even went to the trouble of making sure they were inserted into the Guinness Book of World Records. And whether or not that even makes sense for this claim is something you'll have to think about through the course of this talk. But whether it made sense or not, it was a huge selling point for the game, and it certainly is one of the most enduring features of Borderlands. Around the same time, Minecraft was released. And although Minecraft didn't have a specific marketing plan per se, it sort of was its own marketing, lots of the articles written about Minecraft would mention how big the worlds were that were randomly generated inside it. Each Minecraft world is 32 million blocks wide and 32 million blocks long, and that ignores the height aspect of cliffs. I'm just talking about the surface area here. Which means that in total, a Minecraft world is about 1 quadrillion blocks in area, just in surface area. And if each block is 1 meter cubed, which is a common equivalence that people often use for Minecraft worlds, that means that a Minecraft world is comfortably bigger, many times bigger than the surface of this planet, which is an impressive number. So Minecraft worlds were big, and even though it might not have been a central advertisement point for the game, it was really important. A few years later on, and the Elite series returns thanks to a crowdfunding campaign that brought it back. There hadn't been a new game for many, many years, and Elite Dangerous was developed with 400 billion star systems in it, a huge number. This included real star systems that existed, like the solar system that we're in, using astronomical data, observances from the night sky, as well as models of how they expect the galaxy to be laid out. And the result is a huge galaxy map filled with stars and strange anomalies and planets that you can land on. And it's truly vast and truly desolate in many places. And we'll come back to Elite Dangerous in a minute, because there's quite an interesting comparison to be made with the original Elite. The final stop on our history tour, of course, has to be No Man's Sky. That was released this year, but you'll have probably seen at some point in the last few years its enormous marketing campaign, and really a lot of that marketing was centered around its procedural generator. No Man's Sky is easily the most important and significant example of procedural generation probably ever, because of how much it marketed itself on its procedural generation. Over 18 quintillion planets are in that game, and people made sure that you knew about it. And this is sort of where we are today. We're at this enormous number in this huge game that has so much in it, and we're not really sure what could possibly happen next. But although I tried to present the history of these numbers as if they were constantly getting bigger, there's actually some interesting things to point out about the history of procedural generation. And for the first one, I want to take us back to 1984, to the original Elite. The two developers who were originally pitching Elite to publishers ended up with Acorn Soft as their publisher. And when they described their game to them, they didn't describe it with 8 galaxies in. They described it with 282 billion galaxies in. And the publishers were worried about this. The developers were very keen on this technique that they'd made, this amazing compression technique that allowed them to expand just a couple of numbers into stars and planets. And they realized that the limit of their algorithm was huge. They could pack a huge number of galaxies into the game. But the publishers were concerned. They were concerned that it would make people feel like everything was very artificial, like it didn't have any meaning or point to it. There were so many of them that it was obvious they were artificially generated. What they needed was a number that was bigger than a tiny handcrafted number, but smaller than the ridiculous value they were proposing, which is why they ended up settling on 8 galaxies with 256 planets. And it's interesting to compare this approach to marketing a game with today's approach, which focuses on big numbers and impressive statistics. No Man's Sky takes 584 billion years to explore, or it has 18 quintillion planets, or it has so many animal species to be discovered in a day. It's not that one is worse than the other, perhaps, but that there seem to be markedly different. Something has changed over the course of the last few decades. The other thing that's interesting to note is that even though the numbers seem to be getting bigger, it's not just restraint that kept people from keeping the numbers small initially. Sometimes we just don't talk about numbers. For instance, it might surprise you to find out that there's actually the same number of possible Minecraft worlds as there are No Man's Sky planets. They both use the same random seed, which is a 64-bit integer, which means that the possible values for it are exactly the same. There are 18 quintillion No Man's Sky worlds, and there are 18 quintillion planets in Minecraft. And planets in No Man's Sky are vast and huge, and planets in Minecraft, as we've already discussed, are a quadrillion blocks, each a meter cubed. So they're also huge. And so these two games, even though one traded very heavily on how vast it was, and came out many years after, are actually similar in size, or at least they appear to be on paper. But what do these numbers even mean? Are they actually telling us anything about what's in the generator? Let's forget Minecraft for a minute, and let me ask you to compare these two games. Is No Man's Sky bigger than Civilization V? I didn't even mention Civilization in the history of procedural generation, and the reason for that is that it doesn't really market itself on procedural generation, and there aren't any important numbers attached to its procedural generator. It just sort of sits in the background, producing planets for you to raise your civilization on. So which one is bigger? Let's go and have a look, and let's do some maths. Brace yourself. It'll just be a little bit, I promise. It won't be a really complicated example. But what I want to do is I want to calculate how many possible planets are there in Civilization V. So for this, we're going to look at a standard size planet. The planets are grids of tiles, and the standard size is 84 tiles wide by 52 tiles high. And all of these tiles are tucked up next to each other in a grid, and they all have different values. Now, in Civilization, there's loads of different values and modifiers that they can have. They can have rare resources on them and things like that. For us, we're just going to say that each tile can be one of 8 things. And if you need examples for what they are, they could be things like this. They could be things like oceans, or mountains, or tundra, or ice. But it's not really important. They can be whatever you want to imagine them as. So how many different combinations of tile types are there to fit this standard map size? Well, first of all, let's calculate how many tiles there are in a map. There's 84 tiles wide and 52 tiles high, so in total that's 84 times 52, which is 4,368, which is a fairly big number. That's a large number of tiles. And for each tile, there's 8 possibilities that it can have. So the first tile, there is 8 variations. And then for each one of those 8 tiles in the top left-hand corner, the tile next to it also has 8 possibilities. So that's 8 times 8 for 64. And then for the third tile, it's another 8, so we multiply it by 8 again. And we actually keep multiplying it by 8 for each one of these tiles. So it's 8 times 8 times 8, 4,368 times. And we end up with this number, 8 to the power of 4,368. And this number is enormous. And to give you an idea of how enormous it is, I'm going to try and write it down for you. This number here is the number of planets in No Man's Sky. 18 quintillion, 446 quadrillion, etc., etc. It's a big number. It's a huge number. It's a huge number to think about, but actually to write down on paper, it's relatively easy. It's right there on your screen. It's about 20 digits long. Now let's try and write down 8 to the power of 4,368. Before I go to the next slide, just imagine for a second how big you think this number is going to be. This is the start of that number. So it's 497, 809, 500, 634. All of this is the actual digit written out. Even writing the number won't fit on a slide. And it keeps going, and it keeps going, and it keeps going, and it still keeps going. And it eventually does stop, but this is how big this number is. This is the number of potential civilization maps. And I say potential because I've twisted things and tricked a bit here. I've sort of taken some license. Because this also includes a map which, for instance, is covered in ocean tiles, and Civilization will never generate that. But it gives you an idea of how silly these numbers can be, and how even though 18 quintillion sounds like a lot, actually it might not be. It's just that these numbers don't help you. These numbers don't help you imagine or understand what it is that this generator is doing. And this leads me on to the next bit of the talk, where I'm going to be grumpy for a bit and tell you the problems with using big numbers like this. So the first problem is that it doesn't tell you how varied the things in this generator are. A colleague of mine, Kate Compton, uses this, calls this the 10,000 bowls of oatmeal problem. Every day you sit down and you have a bowl of oatmeal, and even though it is technically unique, there'll be a different number of oats in the bowl, and they'll be at different angles floating in the milk, and the milk will be a different temperature, and there'll be a different amount of it, and a few of the ceramic atoms will have been shaved off the bowl since the day before. But to you, it just looks like every other bowl of oatmeal you've ever had in your life. It doesn't matter how many bowls of oatmeal you have, they'll always look the same. So big numbers don't tell you whether the next thing you're going to see is cool or interesting, it just tells you that there is another one. Which sort of leads me on to say that it's really hard to imagine what these numbers look like. You saw how difficult it was to picture that amount of planets or that amount of civilization maps. A deck of cards, for instance, if you shuffle a deck of cards, the odds are definitely in favor of there never in the history of humankind ever having been a deck of cards shuffled the way you just shuffled it. Which is ridiculous. It's so hard to think about numbers this big or this complex or this small. And so 17 million guns in Borderlands is really as big a number as 18 quintillion planets, because if you can't hold it in your head or do anything with it, it's just a number. It doesn't really help you anything. Another big problem that this has is that it encourages us to design games around wasting things. We give the players buttons that they can press that they can always get new content out of. And what that means is that we don't need to worry whether a piece of content is particularly good, because they can just press the button and get another piece of content. If you don't like a Minecraft world when you spawn it, you just spawn another one. It doesn't matter if there's something beautiful 5 million blocks into the horizon, because it's not interesting enough for you to care. You just hit another one and see if the spawn is good next time. Which, of course, means that you're getting trained to be as wasteful as we are as developers. You're getting trained to not care about the things that you find, the guns that you find in Borderlands, the planets you find in No Man's Sky. You're getting trained and conditioned into this thing where you just want more of stuff. And that's no one's fault, and I should also point out that it's not a bad thing necessarily. Actually, big numbers can be really useful. For instance, they can make us feel very small and insignificant, and I think No Man's Sky is actually a great example of a game which uses big numbers to make the player feel like they're in something very, very big indeed. This was actually a common thing in the Victorian era in the 19th century. People would go to places like the Alps in France, and they'd stand in the mountain ranges and look down at the valleys, and they'd feel this sense of awe and this sense of insignificance, and this feeling that whatever they did with their lives, they wouldn't be able to leave a single dent on this enormous planet. And that feeling energized them and motivated them and made them feel moved, I guess, emotionally. And I think procedural generators can do the same thing. 18 quintillion planets. You could spend your whole life and you'll never visit each one. But even though it can do cool things, I think we should also look for other things that it can do. And in particular, I'm interested in this button that we've been trained to press as developers and as players, and I want to find out what could we do to make people not want to push it. And I want to give you a few examples of things that I think procedural generation can do in the future to make people want to do other things instead. The first thing that I'm really interested in is giving players the control over the procedural generator. So for instance, I'm working on a game called Tombs of Temeria. It's a little prototype, and in it, the player controls a little explorer, and they can move around this procedurally generated tomb and find lots of levers to pull. And as they pull a lever, parts of the world disappear or reappear, as if the tiles in the walls were shifting around. And what's actually happening underneath the hood is that the player is editing the procedural generator as they pull these levers. They're changing parameters and causing the level to regenerate itself. And even though it doesn't look like that when you're playing the game, it just looks like you're exploring a trapped and dangerous tomb, what you're actually doing is interacting with the generator and understanding how one piece of content works. You learn after a while that pulling the levers in one direction will let you open up certain passages or close off other ones. Another prototype we've got working is a game called L System. So if you see those two boxes connected by a green arrow, that's a before and an after in a rule. So on the left-hand side it says, whenever you see a box on its own with nothing above or to the right of it, replace it with a box next to two boxes. And this is a rule that the player has written in order to help them edit the world. And when they execute that rule 4 or 5 times, they end up building a little staircase that lets them get to the key. So here what's happening is the player is writing the rules that the procedural generator is going to use to paint the level. And the idea is that this will be an open world platformer where the player has to decide what rules they need to write in order to solve all of the problems that they're coming up across. We're actually writing a little research grant right now that's hoping to apply some of these ideas into a much bigger research statement and hopefully find some exciting new directions using some wonderful collaborators from the games industry. Another angle I'm really interested in is personal generation. There's something very special about certain kinds of games. Dwarf Fortress is a good example, where the generator tells a story, and most importantly, it's a story that you own. Why is it that people are so attached to their dwarf fortresses? It's not because the worlds that are generated are super interesting or innovative or unique. Actually, most dwarf fortress worlds are very similar. They have the same races, they have the same flora and fauna, similar gods, same kind of metals in the earth, the same tech tree. But what's important about the world generator is that it makes a little story that's all yours. There's a history there, there's a particular religion. Your dwarves have names and they've come from places and you can go and look them up. And it makes the generated content mean something to you. It feels like you're building something over time. And that personal connection to the content means that you're less likely to throw it away. It's about making it feel like you've contributed. You're building a little something here which can't be thrown away easily. And that leads me on to the other future that I think is really important and interesting and cool for procedural generation, which is communal generation. So often games are one of two extremes. Either they are massively multiplayer or massively experienced by many people in the same way. So games like World of Warcraft are a good example because everyone sees the same content. But also games like Call of Duty or Half-Life are kind of similar as well, because even though you're not playing together, you're all playing the same campaign, so you all have very similar experiences. Then there are games which are completely personal and individualized. So games like playing Minecraft offline in single-player mode is a little bit like this. You generate a world, but no one else will ever see that world, probably, and anything that happens in it will be unique to you. You might tell people stories about it, but they'll never experience it or have any interaction with it. What I'm interested in is a middle range in between those two extremes, where content is generated for a small group of people, maybe 8 people to 20 people or something like that. It's big enough to have meaning as a group, but it's not so big that you lose track of what's going on. And a good example of this is actually online Minecraft servers. So if you ever had a group of friends who have a Minecraft server together, it's more meaningful than a single person interacting with a procedural generator. But also because you know everyone who is using this piece of content, the content becomes shared in a closed way. There's not millions of people running around this world. There's maybe just 5 or 6, just your friends or your family, maybe your co-workers, maybe the people you go into school the next day and talk about. And this intensifies that feeling of connection towards procedural generation. It really makes things matter to people, and I'm really interested in games that hit this medium scale, this community scale, this local scale. And I think we can do a lot more with procedural generation in this space. So these are just some of the things that I think we can do with procedural generation in the future, and these are just things that I find interesting. There are loads of things being worked on by loads of different people all around the world. I've got colleagues who are interested in having physical outputs from your procedural generator. So when you finish a game of Dwarf Fortress, you have a little Bayeux tapestry that tells the story of your fortress, or you get a 3D printed model of the room that your last fortress held out in. There's loads of cool features, and this is just one of them. But if you want to find out more, I highly recommend that you tune in to ProcJam's live day of talks on the 21st of October. If you're in Falmouth, in Cornwall, you can come along live. We're at the university. But if not, you can just tune in on YouTube. You can use the live chat to ask questions, and we're going to have a load of really cool speakers there, which we're announcing next week. Then, if you're super up for it, you can actually join in with us at ProcJam. We start on Bonfire Night on November the 5th, and we run through to the 13th. But you can start early or finish late. And maybe you don't want to enter the jam at all and you just want to use our resources. That's cool too. We've got code samples up on the website, loads of free art to help you get started, links to loads of tutorials. Ultimately, we need everyone to get involved in procedural generation so that new people come and express their ideas for what the future looks like. The more people that do this, the more different ways we get to understand procedural generation. And so big numbers, small numbers, numbers we can't even understand or think about. I don't care what the futures are, I just would love to hear your perspective and your opinion. Thanks very much for listening. If you want to find out more, do go to procjam.com. You can check out my game at rogueprocess.run, or you can say hi to me on Twitter. Thanks.